Now, to go along with PLCs, right, we have what came before, which was relay wiring. Right. So let's say you wanted to have a start button and a stop button controlling a relay. Right. So that way, when you push the start button, the relay would turn on. When you push the stop button, the relay would turn off. Right. This is what's known as a latching circuit. So you would say, okay, I go from my 24 volts. I go to my start button, which should be normally open. It goes to a stop button, which should be normally closed. And then I would go to my relay, which would go to ground. All right. So now I push the start button, the stop button's already closed, power would flow through the relay, and down here I would have a coil that when I press this button, it would close this. All right, so we can now control high power devices. Problem is right now, when I let go of that button, it would just open up again. All right, there's no latching. So what we have to do is we have to take this, and we have to connect it back to that start button. So now when I push this, I just put a little dotted line here, so they're all connected. Power would flow through this. If that push button's pressed, it would be down here. It would throw through that push button, through the stop button, through this. All right, that would energize that coil. Now power can flow through the green line, or it could flow down here because this, since that relay is closed, power would now flow through that one contact. All right, so that's called a latching circuit. So this is how all wiring used to be done. It was called relay logic because any time that you needed to have one thing happen while doing another thing, basically put another relay in it. And you put another relay, and another relay, and another relay. So you constantly had all of these relays happening, controlling all these different things. All right, which is good. It got the job done, allowed them to program things so they could press the start button, and when this limit switch got pressed, it would turn this off and turn the next thing on. It's fine, right? But it started to become very complicated. All right, just more and more complicated. So one of the things that we're going to do next class is I'm going to have you guys do a little relay wiring. Get some relays and contactors and things like that. And you guys are going to wire some stuff up for that purpose. All right. Now, if you're asking what is a contactor, just go on the HMI. That should be fine, right? All right. So in the real world, you would see you would have your button. All right. And your button would go up there. All right. And when you push this down, you would have this come out bottom here. And then when you let go, this whole thing would move up, and that would be even with this. And you can screw different contacts on the bottom. So you can say, hey, I need normally open contacts. I need normally closed. And you can just screw more contacts. And the crazy thing here is you can stack them. So you could do, this one would be normally open, and then you could say this one's also normally open, and then you could stack another one on here, this would be normally closed. And you could stack another, and another, and another, and another. You could basically stack to infinity. The problem is, each of these contacts has a small spring in it. So every time you stack more contacts, it gets harder and harder and harder for you to press that button. All right. Also, this stack gets deeper and deeper and deeper and deeper. All right. So obviously that's causing other problems. Now you could solve that by using some relays. So okay, when I press this button, I want you to energize this relay. And you can have 6 relays controlled by that one button press. So that way you can control 12 different applications with that button press. Instead of having 12 contacts stacked. That would work as well. Relays are expensive. So a little bit of give and take. Really easy to press the button, but a little bit more expensive for devices and wiring as well. So there is some give and take going on. But relay wiring is, everything is just hardwired. Now the biggest downside to relay wiring is when you want to make a change. What do you have to do? You have to physically rewire the entire system. If you're like, oh, that conveyor should move until this limit switch, not that limit switch, you now have to open up your control box, run wires from the new limit switch into your control box, and figure out where the old one was connected and hook this one in there. And hopefully that's the only change you have to make, right? Like, oh, let me just disconnect these 2 wires, put 2 new wires in, bada bing, bada boom, I'm done. Most likely not going to be the case. All right. So you have to physically go through, open this cabinet, and rewire everything. Right? Now, how would we do this in the world of a PLC? Well, if we've got our PLC sitting here, all right, and you've got your inputs on one side and your outputs on the other. All you do, so how the wiring works, is you'd have your 24 volts, and that would go to your push button, in this case for our start, and our push button for our stop. This would be one input, this would be input 0, this would be input 1. Right? Then over here you'd have your output, and that would go, say, to your contactor. Just put a circle in for it, and that would go to 0 volts. All right, and that's how we would do this. So when we want to change how the program works, we don't have to rewire anything unless we're adding a sensor. All we have to do is open the program on the PLC and tweak it. So you would just rearrange the diagram. All right. So is the wiring more or less difficult? Depending on how you look at it, it could be more. The projects I've had my students do in the past in the ELE 101, the wiring for the PLC actually used more wires because each input needs 2 wires. One wire that goes to the PLC, one wire that goes back to 24 volts. All right. Where up here, we have 1 wire, 2 wire, 3 wire, 4 wire. So for just my 2 inputs, I'm using those 4 wires already. All right. I guess this uses 6. And then I have 2 wires over here from the output. So that'd be my 6. So I'm using the same number of wires. If I add more inputs, now we start getting to a point where we're using more wires for the PLC. But the wiring itself is actually easier. It's just input PLC, input PLC, input PLC. Just everything's just nice straight down the line. You know, out to the one side of the input, the button goes to the PLC, the other one goes 20 volts. It's a really simple connection. A little bit of give and take going on. But I will show you more, and we'll actually do a relay wiring exercise where we'll wire up some relays. Then we'll do a PLC, a little bit quick wiring exercise for that as well. All right, any other questions for me? Since no one had any before? No? All right, well, that is relay wiring.